Okay, so on this one then, to solve this differential equation, what do we do first? We test if it's exact. Yeah. So this is our m, and this is our n. And we check to see if partial m partial y is the same thing as partial n partial x. So let's find each. So we hold x fixed, we differentiate with respect to y when we do partial with respect to y. So the first one is 0, the second one will be 2x y squared, and partial n partial y is equal to, now we hold x fixed, sorry, this is x. We hold y fixed, we differentiate with respect to x. So this will be 2x, oops, no need a 2 there, it's just 2xy. And this is also 2xy with respect to x. So therefore they're exact. Since they're equal, therefore differential equation is exact. Do you remember the process when it's exact what to do?
These are the partial derivatives of it.
Of some function. So then we know that there exists some function f of x comma y where partial of x has to equal m. Am I right? Okay, and then that means partial of x is equal to x cubed plus xy squared. And partial of x is nothing but df dx. And to get f, we can multiply dx on both sides, and we can integrate both sides, which will immediately get us our f. Integral of df is just f. Integration with respect to x, so x cubed becomes x to the 4 over 4, and xy squared becomes x squared y squared over 2 plus our constant of integration in this case, because we are integrating with respect to x, will be some function of y. Yeah. Now we have to find what that h of y is. Well, we also have another piece of information that says partial y has to equal n, which means df over dy has to equal x squared y plus y cubed. And now we're going to find the partial. The first term we hold the x fixed, so the first term is 0. I'm differentiating this right here. The first term is 0. The second term will be with respect to y, so holding x fixed will be just y. and the derivative of h with respect to y will just be h prime of y, and that has to equal x squared y plus y cubed. Those two go away, and we get h prime of y equals y cubed. Well, h prime of y is nothing but dh over dy equals y cubed. So what we can do, put the dy here and integrate both sides, yeah? Integral of dh is h, integral of y cubed is y to the 4 over 4. So we found our h of y, and we've already determined our f right here. So now we can substitute h of y in f. So f will be x to the 4 over 4 plus x squared y squared times half plus h of y, which is y to the 4 over 4. And since this has to equal some constant c, our explicit solution, we can set this equal to some constant, which we can determine if we had boundary conditions or initial conditions. 1/4 x4 plus 1/4 y to the 4 plus 1/2 x squared y squared equals some constant c to be determined. This does it for our solution.